Hey everyone, we're going to be working in Houdini today. So Houdini works very similarly to Maya. We can orbit around the viewport with the camera in the same way as Maya. So Alt, middle mouse, left mouse, and right mouse clicking and dragging. So Houdini's got a lot of great shelf tools up here. We're going to be using the Pyro Effects shelf. We're going to be using the bonfire. So if you select bonfire, it asks you for a location to put it. I just want to put it in the center. So what I can actually do is control click the bonfire and it'll create the bonfire exactly at 0, 0. So you can see it's taking a while to load because it's doing a lot of simulation just for the first frame. And if we hit play, we can watch this simulation. Looks pretty interesting. And it's going a lot faster than Maya would or Bifrost. So I like Houdini because it just works. So here's our bonfire simulation that we'll start with. But we want to change our object from this kind of cylinder platform to some logs that we want to set on fire. So here is our node editor where most of our work is done. So these nodes here, this is the Pyro node where we can adjust a lot of the settings. This kind of acts as the attribute editor in Maya. So this is where we select our different nodes and then we can change the different values here. So there's a lot of values you can change. Feel free to mess with these and get a more interesting result. But what I want to do is replace the object that we're setting on fire. And that's not available in any of these here because right now we're inside of our bonfire simulation. So I want to go back outside of this to our object menu. And you can see here we have two nodes now. We have our simulation, which we were just inside, and then we have our bonfire geometry, which the simulation is referencing. So I'm going to double click this to go into my bonfire geometry node, and there's a lot more nodes here that all got created when we hit this shelf preset. And the very top one is this bonfire base. If we hit the blue eyeball on the right side of the node, we can isolate our selection to just be looking at this one node. So here's the shape that we're setting on fire. We want to replace this with some logs. So let's grab our logs. I'll do File, Import, Geometry. I'll navigate to my logs and import those. So it's imported the logs, blah, blah, blah. It's imported it as another geometry node. So I want to copy that. Okay, let me go back. So we want to replace this with a file, the log, an OBJ of the logs. And you know, we could, if you wanted, we could resize these to be more log shaped, but I have geometry for the logs that I want to import. So to import our logs, we'll create a new node by hitting Tab, and we can just start typing for the File node. Hit Enter and click to place that file node. So the node exists, but it's not connected to our network, and we're not referencing the file that we want. So with the file node selected, under Geometry, navigate to your logs OBJ. And now if we isolate the selection here, we can see our logs. So we want to replace this object with this one, and it's as easy as clicking and dragging to replace this connection here. So now if we go down and start previewing the rest of these nodes, we can see it's doing all of the same actions now to this different object. And this is why Houdini nodes are great, because we can replace this very first asset and keep all of the settings the same. So we still have a really nice bonfire simulation starting with a different object. So I'm going to go back to my objects and back into my bonfire simulation. And I'm just going to play this through. I'll go back to frame 1 and see how this is looking. So Houdini creates a cache similar to Maya. So once it loads these blue frames, we can scrub through them more quickly to preview them. but it does take a while later as you get later in the frames, as more and more particles get generated, it's going to take longer and longer, especially if we increase the resolution, which is something I want to do because right now I'm seeing a good amount of the voxelization, which is breaking down this volume into cubes. You can sort of see blurred cubes, and that's kind of the equivalent of pixel resolution for the simulation. So I want to make this a little more high quality, increase the resolution, and that's called the particle separation. And you can find that in your bonfire simulation network on your Pyro node. It's this voxel size. So I want to decrease this to 0.1. Just cut it in half. And if I go back to frame 1 and start regenerating these frames, start this simulation again, it's going to take even longer because it's twice as many voxels now. And if you want to preview this in real time, you can create a play blast of your cache, even as it's caching with the little flipbook here. So I'll hit render flipbook. You can change settings to be whatever you want, but by default, it should be okay. It'll open a window where it'll start adding frames that it caches into this window. And so we can play this just as an image sequence, so we can start to watch it in real time. And it keeps adding new frames into it as it creates them. So I'm only going to do 100 frames because this can get pretty heavy. We need to go back outside of our simulation to our geometry here, because this node here, this final out, is the object that we want to output. So to send this to Maya, we're going to use a VDB cache. So we're going to save out each frame of this volume as an image sequence, and Maya can read that as a volume. You can think of this simulation as a 3D image. So it's just an image sequence that we're making, but it's in 3 dimensions. It's a volume. So we're using the VDB file type. So first we need to convert our Houdini simulation to a VDB. So I'll create a VDB convert node. And connect to the first input. The only setting we have to change is what type to convert to. We want to convert to a VDB. And I lied. We also want to add the different groups. So Houdini creates different channels which have different attributes, like we can individually affect the smoke versus the flame, or the temperature and the density. So these are the 4 attributes we want to include in our VDB. They're kind of like render passes, but for volume. So I want to include all these. I'll just click density, I'll click flame, scatter, and temperature, and that adds them all to this group here. Make sure you're set to VDB, and then we want to write this as a file cache. So I'll create a file cache node, hook it up, look at it, and I want to change my type to VDB. This will save it as a VDB sequence. So you can see here what it'll save it as: the HIP name, that's the Houdini project, which first let's save this scene. And this $F4 here represents the frame number. And we'll set the location of our cache. Again, hit save to disk. And that will start writing each frame as a VDB. And this is what we can import into Maya. So in Maya, I want to bring in my campfire FBX. This is the whole object, including the logs. And I want to add my VDB simulation in here. So we'll do this under using the Arnold window. So in Arnold, create a volume. And this volume is looking for a VDB. So we'll give it the file name, location. And we'll just select the first frame, hit load. And you can see it's detected those different channels that we've included. So we have density, flame, scatter, and temperature. We want to import all of these, so just shift select and make sure all of them are highlighted so that it's importing them here. We also want to use a file sequence, and that changes the number 001 to a bunch of hashtags, which means it's looking at the current frame number. This is an expression here saying frame equals frame. So whatever frame we're on, it's going to change this number to that frame. So it's importing different files. So if we're on frame 2, it's going to be importing file number 2. So we've rendered 27 frames so far. So let me go to frame 25. Okay, so I've gone to frame 25. I had to refresh by retaking this, but you can see now our grid has changed size. So we don't see our volume, but we do see a bounding box for it. So we can see the approximate shape. To see our simulation, we need to render it. So let me just open up the render view. So we can see the data's in there, but it's not rendering correctly. And that's because it doesn't have the correct material on it. So we also need to give this object here, the volume object, a volume material. So let me right click and hold to assign a new material. Under Arnold, it is not here, unfortunately. So what we have to do is go into our hypershade, and we'll get some more options in our Arnold tab. So we want the AI volume, and you can just search it. AI standard volume. So I've created it, but now I need to apply it. So with my object selected, I'll right click and hold to assign material to viewport selection. And even though it's not showing up in the attribute editor, it is assigned to this object. So if we render again, now it's rendering correctly, or at least similar to the way it's rendered in Houdini. And from here, we can modify a lot of attributes of our volume. And actually, this is looking really good right off the bat. I'm pretty happy with that. But if you'd like, you can modify this fire even further. You get a lot of freedom here. You can change the color of the flames, the temperature, intensity. Try messing with these and seeing what kind of different results you get. So I'm only seeing the flames right now, but there's also smoke in here. So let me add some extra light into this scene, just with a sky dome light, to see our objects and our flames. Yeah, so that is kind of flooding the scene with too much light. Let me bring it down. And you can put a much more interesting HDRI in here or anything else. I'd also like you to put some nice Arnold materials on here. There are textures provided as well. And you can load in an HDRI and just create a nice campfire scene. And the way this should work is once you change to a different frame, 14, let's say, and hit render again, it's now pulling that frame 14 VDB. So with it set up correctly, you should just be able to render your sequence like normal. And you're off.